Hi, this is Mrs. Cahill, lesson 9.2, lines of best fit. So, a line of best fit. When data are collected, the points graphed usually do not form an exact straight line, but may approximate a linear relationship. A line of best fit is a line that is very close to most of the data points. So we're going to do example 1. Look at the information in the table about the cost of cookies. We'll construct a scatter plot using the data, then draw and assess a line that seems to best represent the data. So imagine your graph has no points plotted. Could you plot those points? Sure you could. When we are at year 0, which is actually the year 2000, it'll be $2.59, which is just below 260. Year 1 would be at 281, so there is no 1 right here, and you're just above the 280. So I know you can get your points in there just fine. Now we're going to draw a line of fit. This is going to sound funny, but one of the best ways to get your line of fit before you draw it is to use a spaghetti noodle and lie it down until it looks like it's fitting the best possible. This line's been put here for us, and what I like about this line is I have about as many points above the line as I do below. Half the points are above and half are below. So it's a pretty good line. In fact, the line is so good, we could use it to help predict future information. Most of the data points are pretty close to the line. It's not perfect, but we can use it as a predictor. And that's what we're going to do here in example 2. Using the same graph, we're going to use our line of best fit to make a conjecture about the cost of cookies in 2013. Notice there was no data for 2013. It only went up to 2009. But we can just extend the graph. So we'll use the line, we're going to extend the line so that it goes on, and we're going to estimate the y value for an x value for 2013. Now, the way you do this mathematically is you take the year we're talking about and subtract it from the year that they put here. They made it handy. They used 2000, so we will get a 13, and I like that. That's handy. All right, so here's my 13, and I extend that up. Where does it hit? How high on the y? Well, right about there. What would you call that? I called it 3.35. So in the year 2013, I think that the cookies will cost $3.35. And that's a pretty good predictor model. Might be a little more, might be a little less. All right, you try it. You're going to use this scatter plot. I want you to draw and assess a line that seems to best represent the data. I'm going to give you a hint. Can you see that the data is kind of all over the place? But I'm telling you to draw a line of fit, so try it. So there's my line of fit. What do you think? By the way, wouldn't you call this one right here an outlier? I don't want to use him to help me predict data. There's my line of fit. Do you think it's very good? No, it's the best one I can make. This data doesn't fit the line very well, but it's the best line I could make considering that data. So most of the points are not close to the line of fit. So that means it's not going to be an excellent predictor model like the last one was. So part B, we're going to use the line of best fit to make a conjecture about the points drivers will score in 2015. Now notice we're at year 1999, so it'll be 2015 minus 1999. So that'll put us at year 2016. And at the year 2016, which would be about here, I might hit at about just under 6,000 or 5,900. Is that the number I definitely will get? Probably not. Again, like I said, this line of fit is not an excellent predictor model, but that's what we get sometimes. All right, so we've got a scatter plot that shows the number of cellular service subscribers in the US. Write an equation in slope-intercept form of the line of best fit that is drawn and interpret the slope and the y-intercept. Remember, slope-intercept, y equals mx plus b. We need m, we need B. Guess which one we're going to get first? We're going to get M. We're going to choose any 2 points on the line. They don't need to be data points. See all those dots? Doesn't have to be any one of those dots. And I would add one more thing that the book doesn't. I would pick points on the line that are kind of far apart. It's more helpful. So here are the points we picked. Notice this point right here didn't have a data point. Actually, neither did this one. There's a data point here. I'm not using that one. I'm using that one. So what are my values? I've got 9 paired with 275, and I've got 3 paired with 150. Those are my ordered pairs. And now I can use my slope formula to get those points. Those are the numbers I told you, and I'll use those to find slope. Remember the formula for slope? y2 minus y1 over x2 minus x1. So y2 minus y1 over x2 minus x1. Those are the numbers we're going to plug in. And then we can reduce 125 over 6. And if I turn that into a decimal, it's about 20.83. By the way, what does the slope mean for this word problem, for this situation? It's 28.3. That means the number of cell phone subscribers increased about 20.83 million people per year. And we could look back. Are we going up about 20 each year from year 1 to year 2? Did we go up about 20? We sure did. A little above 100, a little above 125, give or take, we did. So that's the slope of the line. Now we need to get the y-intercept. Well, we're lucky. We don't have to calculate it. I see it. The y-intercept is where we cross on the y-axis. It appears to be halfway between 175, and the book shows 87.5, which is exactly halfway between. So if we know M, and now we see B, we can write our equation. Y equals mx plus b, we can plug in our numbers. Y equals 20.83x plus 87.5. And that's the equation we would use to make a prediction for the future. Okay, so we're going to use that information for example 4. Use the equation that we just came up with to make a conjecture about the cellular subscribers in 2015. I'm actually going to go back real quick. Remember, this was year 1999, so we've got to do a little bit of math to find out which year we're talking about. So it's year 2015 is 16 from 1999. So the math I did was 2015 minus 1999. Okay. So what are we asked to do? Well, we're asked to find out, hey, at year 16, how many will there be? So that's an x value, and we can plug that in for x in our equation, our predictor model. Now do the math. And we add them up, and we get 420.83 million cellular subscribers. About. That's what we're predicting for 2015, which of course has already happened. All right, let's see if you've got it. We've got a scatter plot here. It shows the graduation rate of high school students. You're going to write an equation in slope-intercept form. Remember, y equals mx plus b. You're going to calculate m. You're going to get b, and you're going to write the equation of the line of best fit. Then when you're done with that, you're going to make a prediction about the year 2020. If you have trouble with this, don't wait for me to do it in the video. Go rewatch the last example, the last 2 examples. Okay, so let's try. First, we've got to pick 2 data points. They don't have to be points on the line. I think this time they are. So when x is 9, y is here. What do you say? Is that about 72, 73? And when x is 1, y is at 60. And we can go plug that into our slope formula. 72, right? 72 minus 60, that's our y2 minus y1, over 9 minus 1. Let's reduce. We get 12 over 8. Reduce some more, and we get 3 over 2. And that's our slope. So far, we know y equals 3 halves x plus b, and we need b. Well, we're lucky again. We can get b right from the graph. It looks like it's going to hit at about 59. So if I know m and I know b, I can write my equation. Y equals 3 halves x plus 59. So we've finished this part. Now they want us to use the equation to make a conjecture about the graduation rate in 2020. Notice my graph's not big enough to extend the line and read my number from the graph. However, I've got my equation. So for the year 2020, when year 0 is 1999, what year is that? How do I find that out? That's when you do this math. The year they want minus the year since. So I'll do my 2020 minus my 1999, and I get 22 years. And that's an x value to plug in. So 3 halves times 22 plus 59, just in case you need a little help, how do you multiply 3 over 2 times 22? Well, 22 can be put over 1, and we could reduce here. 2 goes into itself once, it goes into 22 11 times, and 3 times 11 is 33. So 33 plus 59 adds up to 92. And remember, these were percent. So what does that mean for the problem? Well, based on this data, I made a line of fit and I wrote the equation of the line. And then I plugged in the year 22 to find that it looks like we will have a graduation rate of 92% in the year 2020, which was year 22 that we plugged into the equation. Okay, that's it. You've taken the notes. They're complicated. Go watch them again. And have you noticed you're only doing a couple of problems from the book? And then I've got a nice worksheet to do. Not many problems. I want you to take your time and go slowly. Re-watch your notes.